Okay, today we're going to do a refresher on how to make a graph by hand. First thing you have to make a graph is you have to have data. So my data is here in a table. I'm plotting degrees Fahrenheit as a function of degrees Celsius. So I'm going to make my x value be the degrees C, my y value be the degrees Fahrenheit, and I'm plotting y as a function of x, or degrees Fahrenheit as a function of degrees Celsius. So the first thing I need to do is figure out how to scale my graph paper. To do that, I'm going to look at my data and look at my largest values. I want to make sure that I can fit my largest values on the graph, but I also want to make sure the graph is spread out. You don't want to have a graph that's all scrunched down here in the corner. I also don't want to have a graph that obviously goes off the page. So to save time, I have gone ahead and scaled my graph paper to start with. I've made 3 boxes be 10 for my degrees Celsius on the bottom, and I've made 2 boxes be 10 degrees for my degrees Fahrenheit on the top. Okay, so now I'm going to plot my data. My first point was 7.7, which would be about here, and 44.7, which would be a point right about here. I'm going to make my points pretty big so you can see them. And then my next point is 24, which would be right about here, and up to 75. 75 would be about here. Another point there. And then my third point is 95.1, so that would be right about here. And I want to go up to 203. 1 way. Just lose my place. 95.1. 203 is going to be right up about like this. Now normally you're going to have more than 3 data points. This is just an illustration to do a graph. Now, I always want to make sure that my axes are labeled. And we label the axes with what it is. So I have temperature, on the x-axis, and I always want to show the units in parentheses. So I have temperature in degrees C on this axis, and on the y-axis I have temperature in degrees Fahrenheit. So I'm going to label that with the degrees Fahrenheit in parentheses. Now, we're going to do what's called a line of best fit, or some people call it a trend line. The trend line is the line that best fits your data. Now, it's not a dot to dot. You don't connect the dots. You want to find a line that closely approximates your data. Some points, now this data is actually a little bit too good as it's falling on a straight line. You actually want the line, sometimes if you have real data, you're going to have some points that are above the trend line, some points that are below. That's okay. You just eyeball it to best fit your data. That's why many people call it a best fit line. It best fits your data. Okay, and you can extend it as far as you want. Okay, now I have my best fit line. Now I want to find the slope of this line. You know from algebra class that any line has a formula. Y equals mx plus b. And you know that m is the slope. So m is the slope, and you find the slope by taking the change in y, so y2 minus y1 over x2 minus x1. Okay, so I want to pick 2 points on my line to find the slope. Now it's important you don't want to use your data points when calculating the slope. You want to find some points that are easy to read, that are exactly on your best fit line. Here's one that lies right on the hatch marks. I'm going to use that as a point, and the x value for that point, let's see, is, follow it down again, make sure you get it right. The x value for this point is 80, and the y value for this point is 180. You always want to circle the points that you're using to calculate the slope. Again, they should not be data points. And then put the coordinates on there. And now I want to find another point. Don't pick 2 points right close together. Now, theoretically, you could still get the same slope, but practically, to account for error, you need to pick points that are far away. Here's a point that is exactly on my best fit line, and it'll be easy to read. This point, which I'm going to label down here, is where x is about 3 and y is about 35. Okay. So I've circled the 2 points that I'm using for my best fit line. I've made sure they were far apart, and I've labeled the coordinates. Then I can plug those numbers into my calculation here. It doesn't really matter which point you call the 2 point, x1. So I'm going to call this one x2 and y2, and this one x1 and y1. But it doesn't really matter, because if you do them back, as long as you do them both the same, so I'm going to take the y value here is 180. And the y value for my other point is 35. And that's divided by the x2 point up here is 80. Minus my other x point is 3. So now I just need to do the arithmetic. 180 minus 35 is 145, and 80 minus 3 is 77, so 145 divided by 77 is 1.88. So I've got to figure out how many significant figures I want to keep. Given the precision of my graph, I'm going to keep just 2 significant figures. I'm going to say 1.9. So now I have the value for m. So I have y equals 1.9 x plus b. Now, if you remember from algebra class, b is the y-intercept. Now, when sometimes you'll have data, like if we graph density, you'll have mass and volume. When mass is 0, volume is 0. But that's not the case with temperature in degrees Fahrenheit and degrees Celsius. The y-intercept here for me is about 29. So I'm going to say plus 29. So that is the formula for my best fit line. Y equals 1.9 x plus 29. Now I'm missing some things on my graph. The most important thing I'm missing is the title. We always want to title y as a function of x. And so I have temperature. I'm going to abbreviate just to keep the video short. Temperature in degrees F as a function of temperature in degrees C. Okay, temperature in degrees F, that's my y value as a function of temperature in degrees C. The other thing that's missing from my graph is a data table. You always want your data table right on the graph. So pick an area of the graph that's open, like right here. I'm going to say temperature, and I'm going to have a little chart here. I'm going a little fast. You'll probably want to be a little bit more careful if you're graphing for a class. And my data, I'm just going to write it right here. 7.7, 44.7, 24.2, 75.1, 90, 95.1, and 203.5. So, I have my graph. Just to review to make sure I've got all the 5 things I need on a graph, I have a title, I have my axes scaled so that the graph is spread out, it's not all scrunched up in one corner, and it's not real flat. It should be not real steep and not real flat, somewhat in between. You pick your scale to make that. So I did my scale that gave me a good line. I have my axes labeled with the variable. In this case, both of my variables are temperature. But I have temperature in degrees C. I have the units in parentheses. And temperature in degrees F, again with the units in parentheses. I've done my line of best fit. I've circled the 2 points that I'm using to calculate my line of best fit. I've labeled the coordinates. Then I've done my algebra to find out the equation for the line, found the slope, and read the y-intercept. And I've included my data table. Now, just to see how good I am, if you know the formula for degrees Fahrenheit as a function of degrees Celsius, the formula is 1.8 times degrees Celsius plus 32. So I'm off a little bit, which is the result of probably my data is not perfect and probably my graphic is not perfect. But this is how you do a graph by hand.